Hi everyone, in this video I will explain how to assign oxidation states to the underlying element. Okay, so let's see. In this first in this first one in this first one you can see K2MnO4. So in K2MnO4 the underlying line is Mn, manganese. So we have to assign oxidation state to this Mn. So firstly, we have to we have to assign oxidation states to charges to potassium and oxygen. So here in this, potassium is going to have 1 plus 1. So because plus 1 plus 1. So how many potassium atoms we have? 2. So plus 2 plus. So why potassium get plus 2? Because potassium belongs to first group element. So sodium, potassium, rubidium, cesium. So its outermost electronic configuration is 1. So it belongs to S block element and under to first group. So it have plus 1 charge. So we have 2 potassium atoms. So we can write plus 2. Next, so we have to find manganese oxidation state. So we write it as a X plus. So I told you already, oxygen always has minus 2 charge. So we have 4 oxygen atoms. So minus 2 into 4 equal to 0. So there is no charge upon any element in this molecule. So we equal to this totally equal to 0. Now, so yes, plus 2 plus x minus 8. 2 4's 8 equal to 0. Next, next time, so we have plus 2. We have plus 2. So plus 2 and minus 8. So how can we write it as x minus 6 equal to 0? So then this 6 will go other side. We can write it as a plus 6. So in this, manganese has its charge, it having plus 6. Like this, we have another compound. Another compound is what? Sodium borohydride. So in this, how can we find? So sodium, like we said, how much oxidation charge sodium get? Sodium is also belongs to first group. So S block, first group element, sodium, potassium, rubidium, cesium. So it is all having plus 1 charge, plus boron is having X. We have to find it. Next, hydrogen. Hydrogen also is having one charge. So we have it is minus 1 or plus 1 in this. These are hydrides. So in hydrides, hydrogen is always having minus 1 charge. So hydrogen is having minus 1 because it are hydrides. So hydrogen is having minus 1. So how many hydrogen atoms we have? 4. So 1 into 4 equal to 0 because we don't have any charge. So next we can write plus 1 x minus 4 equal to 0. So plus 1 minus 4, x minus 3 equal to 0, x equal to plus 3. In this compound, sodium borohydride, boron is having plus 3 oxidative state. Next also we have diffusion oxide. In this you can see we have to identify oxidation state to which one, calcium or oxygen. So we have to write it as oxygen 2x. So we have to assign calcium comes under which group? Beryllium, magnesium, calcium. These are second group elements. S block and alkali earth metals, we know that. So +2, it is having +2. All second group elements is having +2 oxidation state or charge. All second group elements, second group S block, alkali earth metals are having +2 elements. All first group elements that are S block, first group elements is having +1 oxidation state, because in its outermost shell S block element, S blocks, it having NS1 and it is having NS2. So the outermost shell can always consider as oxidation states to these elements. So calcium belongs to second group elements. Calcium +2 plus we have to find oxidation state to oxygen. So there is 2 oxygen, so we can write it as 2x, not x, because there is 2 oxygen. So we have to write 2x, not x. So equal to 0. Then 2x equal to this +2 will go this side, it will trace as a -2, then x equal to -2/2. This is in multiply position. When it goes to other side, it became like this. So 2 ones are x equal to -1. Here in this oxygen we have -1 charge. Like this we have to identify this. So sodium bisulfate. So in this sodium, I told you sodium belongs to which group? Sodium belongs to first group, because sodium atomic electron is sodium atomic number 11, so it atomic electron enters into S block, S1. So first group +1 and +1 plus here in this hydrogen gets +1. Hydrogen is always in +1 oxidation state, except in hydrates like this, sodium hydrate, ammonium hydrates. In hydrates only it having -1 charge. Remaining all cases it having +1 charge. So here oxygen gets +1, and we have to assign +1. We have to find oxidation state to x. So it write as this, and oxygen is always having -2 charge. -2 to 4 equal to 0. Next we can write +1 plus 2 plus x -8 equal to 0. +2 -8 x -6 equal to 0. X equal to +6. Here in this S is having +6 oxidation state. Here another compound O2F2. So you can see O2 O2F2. You can see here is fluorine, 7th group elements. 7th group elements, we know that fluorine, bromine, iodine, astatine, these all elements are having -1 charge. 7th group elements are always having -1 charge. We know that in periodic table, so 7th group elements are having highest electronegativity. So these are having -1 charges. So here we have to find the oxidation state to oxygen. So we write it as a 2x because we know there is 2 oxygen atoms, so we write it as a 2x plus I told you Fa is always having minus 1, so there is 2 of fluorine atoms, so minus 1 into 2 equal to 0. Next 2x minus 2, 1 into 2, 2 equal to 0. 2x equal to plus 2 by 2. So this minus 2 goes other side, it became plus 2, and this multiplication 2 is coming to this side, it became like this, divide and 2 1 side. So x equal to 1, and that is x equal to 1, and that one is plus 1 because this one plus. So here oxygen is having plus 1 charge. So this is the explanation. So in any compound, if you want to find oxidation state to particular atom, we have to know the oxidating charge states or charges to the beside atoms, because in every compound you can see potassium belongs to first group element, so it can have plus 1 oxidation state, and calcium is belongs to second group element, it having plus 2 oxidation states. Fluorine is belongs to seventh group elements, all seventh group elements is also having minus 1 charges. So like this we can assign or find oxidation states to many compounds. Thanks for watching. Please like and subscribe my channel. Thank you.